There's a little bit of homework help for homework 3.2.3.B with the county fair, the second set of problems that come from this section. In this case, the first problem that we're looking at is writing a system of linear equations that's going to represent this situation, and we're going to solve the system by substitution and then interpret the solution. So this situation is the basketball team scored 82 points from 2 and 3 point baskets, and then they made 38 baskets altogether. We're going to let A represent the number of 2 point baskets and B represent the number of 3 point baskets. Now, what we need to really pay attention to is this. We need to pay attention to the total team points, and we need to pay attention to the total number of baskets that were made. We also need to pay attention to how the points go. If you're familiar with basketball or not familiar with basketball, the 2 point shots are worth 2 points, obviously. 3 points worth 3 point shots. And so what we need to think about is the number of points will have to include 2 point and 3 point shots. But the number of baskets will just simply be the number of shots that were made. So when we talk about the number of baskets that are made, this would be the one that equals 38. With that one, it doesn't matter that they're 2 point or 3 point shots necessarily. It's just counting them as a basket as a basket. And so when we talk about this, we would have to have any number of 2 point shots, A, plus any number of 3 point shots, B, would be combined together to make 38 total baskets. When we start talking about the amount of points that are scored, then we have to talk about 2 points per 2 point shot plus 3 points per 3 point shot, and then we get the total of 82 total points. And so we have to consider those two pieces with these two equations, recognizing that the number of baskets made does not include the points per shot, but the points that are total or points earned do include the points per shot. And now when we have these two equations, we can start using those to actually figure out how many of each type of baskets were made, how many 2 point baskets, and then how many 3 point baskets. Now, to be able to make this one work, we have to consider a little bit more of the element of substitution, specifically that we don't have any variables that are already by themselves. What we'll need to do is take the equation A plus B is equal to 38, and we will need to isolate either the A or the B so that we know that one or the other is equal. In this case, I'm going to take and get the A all by itself using subtraction property of equality, and that means that the number of 2 point shots would be equal to 38 total baskets minus the number of 3 point shots. Once I have this value, I can take, just like we did in previous problems, I can take this value right here, which is now what I can understand as the value of A. And this value will come across and be substituted right here for this value of A. So now when we do this, let's go ahead and we'll see how we're going to set that up. We would take 2 times A normally plus 3 times B would equal 82. But now since we're talking about substitution, we want to take out this value of A and we're going to replace it with what we know A is equal. We'll put that value right here and then we'll put it in parentheses. 38 minus B will be our value. And now that we have that value substituted, what I can do is go ahead and start solving. You'll notice that there's no longer an A in our equation here. All there is just the B values. And so 2 times 38 will equal 76. 2 times a minus B would equal a minus 2 times B plus a 3 times B is equal to 82. I would use the subtraction property of equality. Whoops, 72. And then I would combine these two like terms to get B is equal to, and this will tell us the total number of B, which is actually the 3 point shots. And so I would be able to fill in this value right here. And then I'd come back to the original. Once I know what B is, then I would say A plus whatever I found down here in this one is equal to 38. Once I know what that B is, and once I know what that A is, I can test it to make sure it comes out to 82 points following that operation of substitution. I know that this may not seem like I'm telling you exactly what to do, but I can't give it all away. This is a homework piece and I need to see what you can come up with. So give that all a shot there, and then what'll happen as you're done, you figure out the number of 2-point shots and the number of 3-point shots. That's when we go ahead and put this into the system as an ordered pair, giving us a solution. Whatever you came up with for A will be first, and then whatever you come up with B will be second. The next section of this is 3 different systems of equations, and your job is to go ahead and solve using substitution. Now, it is possible that you will get either one solution, no solution, or infinitely many solutions. But the process of finding these out is all the exact same. You'll notice here in this first one that we see 9 times x plus y is equal to 16, and y is equal to 7 times x. As a system, what that means is that this y and this y have the exact same values. Since we understand that, this value of 7 times x, or this value of y, can replace this value for y and become 7 times x. What that will mean is that now this equation, since this y and this y are the same, this would become 9 times x plus 7 times x is equal to 16. And this will help us to understand what x is going to equal. Once I know what x is, I can substitute it back in to my equation, my original equation, and I can find out that this would be 1. So I believe y is going to equal 7. And once I have that value here, then I can come back to my original equation to figure out what the value would be right here. If y is 7, I see 9 times 1 is 9, 9 plus 7 is 16, and now I know for a fact that my ordered pair is 1 for x and 7 for y. You'll need to show all that work right there and upload that work right here as a picture. If I can't follow your work, if your work doesn't support your answer, I can't give you any points. Looking at the next system, we would follow with the same process. We can take this value for y and plug it in where this y is right here. So what we would see is 3 times x plus 1/2. And this is the part where we change it just a little bit. Instead of writing y, we're going to put negative 6 times x plus 11, because we know that this value right here is the same as y, so we're going to replace that y with it. And then we will simply finish the equation. Now, from here, it's a matter of distributive property and then solving for x. We have 3 times x plus a negative 3 times x plus 5 5/10 is equal to negative 3 5/10. And what I would like for you to pay attention to on this part is this. 3 times x plus negative 3 times x is actually 0. And what I'm left to compare is 5 5/10 equal to negative 3 5/10. I know that that's a false statement, so remember what happens when we have a false statement. And that is enough information for solving this system. Remember, obviously this is not one solution, so is this a no solution situation or infinitely many solutions? Give your answer here, and again, upload your picture here. Number 3, we'll work with our substitution again by taking our value of y and substituting it in right here to the equation. And so we'll start with our values, 2 times x plus 4, and then normally we would have y right here is equal to negative 32. But instead of y, we're going to replace that with the value of y, which is negative 1/2 of x minus 8. Now with this one, I won't go quite as far as on the previous one, but I will show you what we get here. From here now, I can simplify using distributive property. 2 times x plus 4 times 1/2 is times negative 1/2 is a negative 2 times x minus 32. Finish simplifying, see what's left over, make a comparison, and decide how many solutions there are, 1, none, or infinitely many. Don't forget to upload your video or your picture. That's it for this assignment. Let me know how else I can help.